everyone, and welcome to this lecture in the hands-on large language models series. Today we are going to start looking at a topic which is called as advanced text generation tools. So let me mark this with a different color over here. Advanced text generation tools and techniques. So first let me try to motivate why we are learning about this topic. Until now, we have learned about prompt engineering. So if you recall, in the last 2 to 3 lectures, we looked at several different examples of prompt engineering. We started with basic prompting, and then we looked at how to create complex prompts. We looked at a 7-step procedure for creating a prompt by giving things such as the persona, instruction, data format, information about the audience, the tone of the response which we want, etc. Later, we learnt about chain prompting, chain of thought prompting, tree of thought prompting, and then we also learnt about why it is important to have some safety guardrails. So we cannot allow the LLM to just come up with any responses. If we are wanting to deploy our product, we need to make sure that the responses produced by the large language model are safe, the responses are ethical, they do not contain abusive language, etc. So we saw some tools and frameworks which can help us do that. So you must be thinking that, okay, that's it, right? We learnt about different type of prompts and then we get the responses. That's all for language models. But this is just the tip of the iceberg. This is just the starting. If you want to be a serious large language model engineer, or if you want to deploy large language models in big companies, you need to start learning about some advanced concepts. And that will be the introduction of today's lecture, advanced text generation tools and techniques. What are these advanced concepts and why do we need to learn about them? Let's try to understand further. So the main question which we are trying to ask is that we are getting LLMs to output what we want through prompt engineering, but can we go further? What can we do further to enhance the LLM output without needing to fine tune the model itself? So one way to make the LLM output better is to fine tune, which would mean that we need to retrain the LLM model. And let's say we do not want to do that. We do not have the time, neither do we have the budget to retrain an entire large language model. So what are the techniques which we can use without fine tuning the model itself? In subsequent lectures, we are going to look at 4 such techniques. The first is related to the model input output itself. The second is related to the model memory. The third is something which is called as agents. And the fourth is called as chains. This chains is kind of an underlying framework which binds everything together, memory plus model input output plus agents. But we are going to learn about all of these 4 things. These are advanced concepts and that will take your journey into large language models deeper and you will be able to do much more powerful things. Okay, so first of all, if you are just using ChatGPT, so if you go to ChatGPT and if you are just interacting with this tool, you won't need to learn about any of the things which we are going to learn, because ChatGPT is a product and OpenAI has taken care of many things under the hood. But this techniques which I'm teaching you will be very helpful if you want to build something from scratch, or if you want to build a custom LLM application which you have deployed, let's say, and you want to make sure that that application uses less memory, you want to increase the speed of that application, what will you do? That's one example. The second example is you want that LLM application to interact with external tools to achieve more complex tasks. Then what will you do? That's when agents come into the picture, for example. So when you are building these custom applications and when you are running custom code in Google Colab, that's when you will need all of these things. So whenever you are working with Google Colab, you will need to dive a bit further into more complex concepts. If you never use Google Colab, if you are just using ChatGPT, then that's still at a very basic level. So let me explain all of these four concepts at a fundamental or at an introductory level, and in subsequent lectures we can go into detail regarding each of them. Okay, so first is related to model input and output. You may be surprised, but there are several things which we can do with the model input itself to make sure that the output is, I would say, produced faster and it consumes less computational resources. So the way the schematic works is that we have an input, we have a large language model, and then we have an output, right? We are going to learn certain techniques which are called as quantization methods. What quantization methods essentially mean is that so the LLM model has certain parameters, right? Let's say 175 billion weights, and each weight takes up certain amount of memory when you run the large language model. So the goal of this is, can we reduce this memory and still can we reduce this memory requirement and still produce accurate information? So imagine if your model currently takes this much amount of memory with 175 billion parameters. And what if I tell you that there are certain techniques which can help you reduce this memory requirement to very less amount of memory, and still you will get a reasonably good output from the large language model. When you are working at a production level, such kind of things are extremely important to know and understand, because this directly relates to your cost. The more memory an application takes, the more costly it will eventually be. Whereas if the memory is very less, the time for convergence will also be less, and the cost which is needed to run that LLM application will also reduce. That's why we have to think of model input and output methods. This is related to loading plus working with large language models. That's number one. Number two is related to memory. And you might not have seen this issue if you have just interacted with ChatGPT. So, for example, here I have, let me interact with ChatGPT saying, I am Raj. What is 2 plus 2? So, ChatGPT says that 2 plus 2 equals 4. Then I'll say, what is 2 plus 3? Let's say. And then it says that 2 plus 3 equals to 5. Now, let me check if it has memory, which means that I have given one prompt, but now I want to check whether it still recalls my name. And then I'll say, what is my name? So when I have asked what is my name, ChatGPT says your name is Raj, which means that some memory is being retained, right? When you are using the GPT application, it already has memory. So let me actually ask maybe 10 of these prompts, and let's see if the memory is still retained. So now I'm asking 2 times, here it's 3 times, 4 times, 5 times. I'll do this 5 more times, and then I'll ask it my name again. So 7, 8, 9, and then one last time, 10. Okay, now let me ask ChatGPT what is my name, and then it says that your name is Raj, which proves that memory is being retained. And you can actually interact with ChatGPT huge number of times, and it does have that memory buffer. But if you go to Google Colab and if you make an API call, if you make an API call to ChatGPT, and if you say that my name is, let's say, this, and what is 1 plus 1, it will say that the answer is 1 plus 2, right? But in the next code cell, if you ask what is my name, it will say that I am unable to determine your name as I don't have the capability to access personal data. So when you are working with production level applications, or if you are doing research, you will need to work through the Google Colab interface. So you will need to learn methods which provide memory when you are making API calls. and that also will be custom memory. So you can do things like, I want to retain the memory for the previous 5 conversations. Let's say I want to retain the memory for previous 5 conversations, or I want to retain the memory for the previous 100 conversations. And that also has several implications. The more memory you retain, the more space your application will take, and it will consume more resources. The less memory you retain, it will consume less resources, but then you cannot reference something you asked previously later in the conversation. All of these things are extremely important. Let's say when you're building a custom chatbot, imagine you're interacting with the chatbot for an airline or for a restaurant. You ask 3 questions, and then after that the chatbot forgets what you interacted with it. That would not be very helpful for you, and so then that chatbot product is essentially a failure. So that is why memory becomes such an important thing to consider when you are learning about advanced concepts in large language models. The third framework, which is extremely important, is agents. So you must have heard about these terms agents or agentic frameworks or agentic approaches. Microsoft even has a library for deploying agents which is called as Autogen, and this is called agentic AI. If you go to Google right now and if you search agentic AI, you will see that this is a very popular term right now, and a lot of funding for companies and for startups is also flowing into this space. And many students do not understand what is the difference between large language models and agents. But there is a very clear difference between both of them. And once you understand the difference, you will also understand why agents are so popular. Imagine you're making travel plans to go to Norway to see the northern lights. I can go to chat GPT and I can ask questions like, what is the best time? What is the best time to visit Norway to see the northern lights? Let's say I've asked this question to chat GPT, and then the response is the best time to visit Norway is between September and early April, when the nights are longest and the skies are darkest. But now, as humans, we want comfort, right? So I don't want to do the booking, I don't want to do anything. I just will tell ChatGPT that here are the dates where I want to visit Norway, here is my budget, and I want ChatGPT to do everything for me. Go ahead and book the tickets for me, book the hotels for me, and then send me the confirmations. If you give this command to ChatGPT, it will not be able to do it because it is a large language model which just predicts the next token. It's not an agent, but an agent can take action, which means if you learn how to train AI agents, you will be able to do all of these things. You will eventually learn how to use an agent to perform tasks such as booking a flight, booking a train. Agentic systems are not that advanced yet, but it's only a matter of time when humans give one command and the entire flight ticket will be booked and sent to your Gmail. It's only a matter of time before something like this happens. And that's why people are betting a lot on startups, new startups, to come up with the first version of agentic AI implementation. So if you want to learn about LLMs in a more advanced manner, you really need to know about agents. For example, you can, let's say, if you're doing Python code, you can ask ChatGPT to generate the code. But what about the validation, and what about implementing changes from its own mistake and running the code again? What if you want to completely automate this process? So you can have one agent to generate the code, one agent to evaluate the code. So the agent which evaluates the code passes the changes to the agent which generates the code. And this loop can continue till the entire code generation process is fully automated. That's the way you can think of agents and how powerful they can be. So we will learn about a basic introduction to agents in the subsequent lectures. And then the final thing is chains. So if you have multiple modules, let's say if you have added memory, you have added an agentic approach also. And if you want to chain all of this together to finally package it into an application, that's when you have to use chains. And the main description here is that chains help to connect different methods and modules. Since we are already at chains, that brings us to the framework through which we are going to implement all of these things which I've mentioned to you right now. There is one framework which is extremely popular, and through that framework, you can implement quantization, you can add memory, you can define agents, you can also define chains. So you can chain multiple objects together, and that framework is called as Langchain. So if you think of Langchain itself, the name, you will see that it can be decomposed into two parts: language and chain. Now I hope you understand why the chain is such an important component of Langchain, because we are going to chain or attach multiple components together. And why language? Because it's related to large language models. So if you type Langchain on Google right now, you'll be taken to their website. But first you can go to their GitHub repository. If you scroll up to their GitHub repository, you can see the stars on this repository. You'll see that there are 95,000 stars and 16,000 forks on this repository, which is a huge amount. I don't think I have seen any repository with these many number of stars and this very high number of forks. The reason this is so popular is that all the startups, all of the researchers who are deploying projects and products using AI, huge portion of these people are using LangChain. It's pretty much an open source application where you'll see that contributors are around 3,000, and this is used by more than 100,000 people. Now, if you look at the definition of LangChain, you will see that LangChain is a framework for developing applications powered by large language models. So let's focus on this definition again. It's a framework for developing applications powered by large language models. LangChain will not teach you how LLMs work. It is just a framework which integrates different components together, and when you assemble these components, you get something very powerful, and that can be your LLM product or your LLM app, right? So this is the LangChain GitHub repository, and you'll see that there is also a website which they have where they collaborate with industries and companies to help them build products. So this is the Langchain website, langchain.com. It's probably one of the most popular and reliable production companies right now. All right. So the next thing what we are going to see is a schematic of how Langchain works. And there are usually four components. All of these are the ones which we learnt about earlier, except for retrieval. But if you see the different models or modules which can be chained together in LangChain, and that's what gives LangChain so much power. The first component is model input output. So we can start with prompts. We can chain the prompts with a language model, any language model, open source, closed source, both are fine. Then you can add memory to the language model. There are two ways to add memory which we'll learn about: conversation memory and summary. Then the third thing which you can do with LangChain, which we did not learn about in today's lecture, is retrieval. Retrieval is a very important thing. You must have heard about retrieval augmented generation. Basically, if you have additional documents which you want to learn, which the LLM can learn from, this is different than fine tuning. But if you want to provide additional documents as data, then you will have to learn about retrieval, how to upload those documents, embeddings, vector databases, etc. But all of these can be chained together: model IO, memory, retrieval. You can even add agentic approaches using LangChain, which means you can define powerful agents. The travel agent which we talked about, the code agent which we talked about, all of them can be defined in LangChain. In fact, there's a framework called React, REACT. So if I search about it, React LangChain agents. So this is the React. This is the React framework, and using this you can actually create agents and you can run the agents. So if you can see the different components here, you will see model IO, prompts, LLMs, etc. can be chained. Then you will see on the left hand side there is retrieval over here, embedding models, vector stores. Then there are agents over here. We are going to learn about all of these. So you can click on this thing to see the React logic. So React is reasoning and action, and it is based on this paper, synergizing reasoning and acting in large language models. It's again become a very popular paper. I think it was first published in 2022 and refined in 2023. Okay, so when we learn about Langchain in subsequent lectures, we are going to see how to chain these different modules together and how all of these modules will come together into a very powerful application. So this is called as the Langchain workflow, and you can see this entire workflow on their website as I was just showing you right now. Look at this left hand side, which they have model IO, retrieval, composition, agents, etc. You can see all of this, and then they also have chains, which shows you how to merge different things together. Don't worry if this is confusing right now to you or also a bit scary. We are going to learn all about this in the subsequent lectures. We'll start with quantization, which is model input output, and then later, as you see in these notes, we'll move to chains, then we'll move to memory, and then after chains and memory is done, finally we'll move to agents, where we'll create our own agents and deploy them using Langchain. This brings us to the end of today's lecture, where we learnt about 4 components of advanced large language models, and those are model input output. Let me mark them with a different color. Model input output, then memory, agents, and chains. There is also retrieval, and all of these components come together under a unifying workflow which is called as Langchain. There are some other workflows also which are now coming up, and some other workflow may become the most popular in the future. But when this video is being recorded, Langchain is still the most popular workflow. So we are going to learn about that. Thanks everyone. I hope you liked this lecture. In the subsequent lectures, we'll be having a mix of whiteboard notes based learning, plus we'll code through Google Colab. Thanks everyone, and I look forward to seeing you in the next lecture.